Welcome once again to Mr. Slaney's YouTube channel. And at this point, if you're watching this and you're preparing for a unit test on rational functions, we've been talking about them for a few weeks, and all of a sudden you're walking down the street and you see this goddamn thing. F of x equals x squared minus 4x minus 21 over x squared minus 9x plus 14. Now we got some questions, right? We've got to, let's find the vertical asymptotes. Let's find the horizontal asymptotes, the wholes, the zeros, and all that. Now, horizontal asymptotes take us all the way back to that lesson in 1.7. Let's start here, right? We don't need to do everything in order. Horizontal asymptotes ask us to find the end behavior, right? Now, when we first started talking about end behavior, we were talking about things like, this box, right? Up, up, down, 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 up, and so on and so forth, right? But end behavior is not always, up, up, and down, down. End behavior can be a constant, right? Our graph doesn't need to look like one of these. Our graph can actually end with end behavior, this way's, we might have end behavior of like -2, right? But how do we know? Well, back in 1.7, you got some notes very similar to this. God, this makes for some excellent screenshotting if you're one of, if you're a student or something. Let me pause so you can do that. Ooh, someone's walking a dog outside. Anyways, you've seen this before. End behavior rules, if we're even, something like 2x squared, I don't even care about this. I don't even need to look at it. We're just looking at those highest exponents. Then my end behavior will be the ratio of leading terms. Bottom heavy and top heavy. Bottom heavy in particular, just y equals 0. This bad boy, x cubed, is growing so much faster than everything. Big denominators create small values. Or if you're top heavy, in which case this is a little bit more complicated. That could be a whole nother video, but be most comfortable with case 1 and case 2. Let's go back. This is definitely even, right? X squared. Don't forget that there are these coefficients of 1. My horizontal asymptote will be y equals 1, right? Really 1 over 1, but who cares? This implies, of course, that my limit as x approaches infinity of this f of x is 1, and same thing on the negative side. Right? And this just means, yeah, there we go. What this means is that on our graph, right, my function, who cares what's going on in the middle, but on the ends, we are level with 1, right? Level with. A little bit more complicated than that if you're a math professor, but if you understand that this means that your graph loosely looks like this, then you're fine in my book. Let's talk about wholes. I'm just going to copy this onto my next page. F of x equals x squared minus 4x minus 21 over x squared minus 9x plus 14. Now, there we go. For a lot of this, life is a little bit easier if this were in factored form. I see I've got x squared minus 4x minus 21. I need to think, what are two numbers that multiply to -21? I'm going to put that over here. How do I multiply to -21, but add up to negative 4. Let's think. I'm betting there's a negative 7 in there and positive 3. Is that right? Yes, I'm the best. So I can rewrite my numerator, x minus 7, x plus 3 over, let's see, two numbers that multiply to 14 and add up to negative 9. 2 and 7, but they both got to be negative. Negative 2, negative 7. Ooh, hot dog. Right? Because now, if I'm looking for holes, right? How do I find holes? I find holes if I can cross out one of these factors, right? Boom. I have a hole at x equals 7. Right? You have a hole, and I'm just going to make a slight edit here. You have a hole if this individual factor is even, right? X minus 7 over x minus 7, or if you're top heavy. So the red is not reality, right? If this were a 2, we would still have a hole at x minus 7. All right. Zeros. I look at my numerator exclusively, right? So x minus 7 over x minus 7. Well, the x minus 7 is a whole. That's not a 0. We can't plug in 7 to this function. But x equals negative 3, right? If I'm looking here, that's going to be the 0, right? The numerator tells us where the zeros are going to be. Where f of x is 0 is where the numerator is 0. And now let's do the hard work. Let's do the vertical asymptote. The number one rule of pre-calc is you can't divide by 0, but not all divisions by 0 are created equally. Now, what do I mean by that? I mean, let's look at our function. I'm going to take a quick detour. God, I use so much paper. F of x equals x minus 7, x plus 3, x minus 7, x minus 2. And not all divisions by 0 are created equal. If I plug in 7, I get 7 minus 7, 7 plus 3 over 7 minus 7, 7 minus 2. This is 0 times 10 over 0 times 5, 0 over 0, right? That's a good indication that you have a hole, probably. Or something much more sinister. Bum, bum, bum. But when you just divide a number by 0, so for example, when I plug in, right, this is still bad. But if I were to try and plug in 2 minus 7, 2 plus 3, over 2 minus 7, 2 minus 2. Now I'm looking at, what is that, negative 5 times positive 5. Hey, I didn't realize that would happen. Negative 5 over 0 equals negative 25 over 0. You plug in your value of x that's bad and you get a whole number like 25, a number like 25 over 0, that's a pretty good indication that you have a vertical asymptote. Anyways, there's more to it than that, but let's keep things within the scope of our course. We know that we have a vertical asymptote at x equals 2. But anytime you have a vertical asymptote, remember that could look, at the asymptote, you could be going up on the left and down on the right, or up on both sides if you're truly disaster. But how do you know what exactly your vertical asymptote looks like? Well, you have to take your limit of your function as you approach 2. Now, limit as x approaches 2, let's start with the left. I have to include this minus. X minus 7, x plus 3, x minus 7, x minus 2. And my number that I'm going to think of, right? Because that's, I don't like to work too hard. I don't want to calculate this. I know that I'm either going up or down, right? I'm on the left. What's the number to the left of 2? That's 1.99. And I'm going to plug that in. If I plug in 1.99 to 7, I get a negative number. If I plug it in here, I get a positive. 1.99 minus 2 is negative. The 1.99 minus 7 is negative. A lot of negativity here. This ends up being negative divided by positive, right? Negative times a negative is a positive. Negative times a positive is a negative. Consequently, this whole limit is negative infinity, right? Negative times a positive divided by a negative times a negative. On the right, the limit as x approaches 2 on the right. Same thing, x minus 7. This is so much easier in factored form. X plus 3, x minus 7, x minus 2. I'm going to use green so I don't get caught up. Number just to the right, 2.01. I'm going to plug it in. 2.01 minus 7, negative. That's negative again. This bad boy is still positive, but this is also positive. Very interesting. Now, negative times positive is negative. Negative times positive is negative. Again, I'm dividing a negative by a negative. Consequently, this limit is positive infinity, right? What does this mean as far as the behavior of this f of x around x equals 2? That means that close to x equals 2, right? This is the so part. So close to x equals 2. F of x goes, let's see, down. And was that on the left or right? I'm such a silly goose. Left. On the left of x equals 2. And up, right, positive infinity, on the right of x equals 2. Right? All sorts of fun stuff that I could ask around these. But vertical asymptotes are tricky and gross and weird, but you know, they are what they are. Let's see, did we answer everything? Did we even did a little extra vertical asymptotes because we did the behavior close to my VA, right? Those are those limits that we took. Let's see, we did this, and this. Where is this function positive or negative? Ah, let's do this because everybody loves it and everyone's awful at it. Let's see. Ooh, look at how little paper I have left. Let me copy over my function. F of x equals x minus 7, x plus 3, x minus 7, x plus 2. Now, I have another video on this. We spent about a day and a half learning how to do these problems, where's positive, where's negative. Let's get rid of this for now, and you know, let's start with where is this bad boy negative, right? Let's graph. Let's see, so many opportunities for colors. Let me do my graph. And just like I promised in all my other videos, you know, we don't need to graph anything too complicated. We know that we've got roots at 7, 2, negative 3. This is going to be such a weird looking graph. My first parabola, and I'm going to really give it some vertical, some shape, elongated. That is my, blue is my numerator. Green will be my denominator. Definitely far from perfect, but I've got enough to cook with some gas. All right. Right now, I'm trying to figure out where is my whole fraction below 0? You are below 0 if your graphs are on the opposite sides, like they are in between -2, -3, and +2 here, right? Let's see, to the left of -3, these are both positive. In between 2 and 7, these are both negative. After 7, my green and my blue are both positive. So, where am I negative? In between -3, right? -3 is less than x is less than 2. This is just how you say, this is how you technically say between -3 and +2. Conversely, where am I positive? Right? It's a reasonable question. Where am I negative? Where am I positive? Two problems for the price of one. Oh, I already have the graph. I'm the best. Well, I'm positive. I'm positive that I'm positive. Ha 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 ha. To the left of -3, right? Both my graphs are positive. So to the left of -3, how do I write that? X is less than -3. In between 2 and 7. 2 is less than x is less than 7. And after 7. Weird things happen at the roots. If you gave me x is greater than 2, I'd probably mark you correct and say something about it when I saw you. You know, at the grocery store or something, because I'm a regular person. So this is just a cute little summary of all the possible things that we know how to do with rational functions. That's why this video is so long. We figured out where will my function be positive or negative, right? That's what we did on this page. We figured out my holes, zeros, and vertical asymptotes. The holes are where we can cancel out or we're top heavy with a particular root. My zeros are where my numerator is 0, but not my denominator. Vertical asymptotes are when I'm bottom heavy with one of my roots, right? Specifically bottom heavy with one of the roots. The end behavior is the one that I really want to touch on. We know, let's actually see if we can get a faint graph just to sum this all up. And then I'll leave you alone. You're on my YouTube channel. Whatever. What do I know about this graph? I know that this graph goes to 1. I know that this graph has a hole at 7. So whatever I end up drawing through 7 will have a hole. I know that at 2... Ooh, this is a good opportunity for another color. At x equals 2, I go, make sure I don't F this up. Left, I go down. Right, I go up. What am I doing with the green? And I think that's all. Oh, I have to cross the x-axis at -3. So I have to cross the x-axis at -3. Notice my arrow is pointing, going to be level with 1. I know that when I connect these two, I need to have a hole at 7 when I just draw that hole. And just to verify, my graph is only really negative from -3 to +2. Everywhere else, my graph is positive, right? To the left of -3, positive. In between -2 and 7, positive. After 7, positive. That's actually not bad. That is, you know, if we look, I'm not going to position it differently, but it's not too far from the actual graph if you were to pop this bad boy into Desmos. Thanks for watching. If you made it all the way to the end of this video, Tell me that your favorite Pokemon is Gyarados, and something good will happen. All right? Tell me that your favorite Pokemon is Gyarados. Hope you're having a good day. Talk to you soon.